Let's further understand ratios by solving some problems. Welcome to Mathematics of Engineering. The first example requires the ratios 2:3, 3:4, 5:6, and 1:5 be arranged in ascending order. There are four ratios to be arranged, but by merely looking at them in their column form, it's difficult to start the solution. However, if we transform them into fraction form, it would be easier to identify which fraction is smaller than the other. This time, we have 2/3, 3/4, 5/6, and 1/5. To be able to clearly say which comes first in the order, we take the LCD, or the least common denominator, of the ratios. With 3, 4, 6, and 5, the least common multiple is 60. So we continue working out on the equivalent fractions. For 2/3 to turn into 1 with 60 as denominator, we can check that 3 is multiplied by 20 to make 60. If we multiply the numerator by 20, we get 40. Next is 3/4 transformed into a denominator of 60 by multiplying 4 by 15. Thus, the numerator is 3 times 15, giving 45. The third ratio is 5/6, which is multiplied by 10 to change the denominator into 60. Then the numerator becomes 50. The last ratio of 1/5 is transformed into its equivalent by multiplying the parts by 12. So the numerator is 1 times 12, which makes the equivalent 12/60. Now that all fractions have similar denominators, we can arrange them in ascending order as 12 all over 60, 40 out of 60, 45 all over 60, and 50/60. Then taking their designated ratio, we get 1:5, followed by 2:3, then 3:4, and last is 5:6. The second example is a word problem. It states that the sum of the squares of two numbers is 244, and the ratio is 5:6. We are to determine the numbers. First, we can assign the two numbers as A for the first and B for the second number. From the first condition, it says that the square of A plus the square of B is 244. Having two unknowns, we should still look for another equation, and that comes from the ratio. The ratio is given as 5:6. This is the relationship, but the numbers can be solved when we let x be the multiplier. So now, the numbers in the relationship is 5x is to 6x. 5x is the first number we denoted as A, and 6x is B. The next step is to plug the numbers in terms of x into the first equation. A squared is now the square of 5x. B squared is the square of 6x. Add them and equate them to 244. By simplification, we get 25x squared plus 36x squared as 244. Add similar terms and get 61x squared as equal to 244. X squared is isolated by dividing everything by 61, which results to x squared as 4. Then extract x by taking their roots, leading to x as 2. Now we can identify the numbers. With a as 5x, where x is 2, we get 5 times 2. So a is 10. B is 6x, which is then computed as 6 times 2, or that is 12. Example 3 has two numbers with a ratio as 3:4. Also, their total is 63. We are again to determine the numbers. We jump to the second condition, where the sum of the numbers is 63. If we let the numbers equal to a and b, they should add up to 63. At this point, instead of looking for the multiplier like what we did earlier, we can just say that from the ratio of 3:4, add them to get 7. So, 63 is 7 all over 7. And the numbers are 3 out of 7 and 4 over 7. Therefore, we can find the numbers directly, as 3/7 of 63 is 27. This is the first number. 4/7 of 63 is 36, and this is the second number. The next example is another word problem stating that the ratio of two numbers is 3:7. The supporting condition to the ratio is their least common multiple, which is 210. Let's focus on the ratio first. We don't have any direct equation for the numbers, as all we know is their LCM. So the ratio should be transformed into numbers first, and that is by multiplying a variable, say x. With ratio of 3:7, the numbers are related as 3x is equal to 7x. 3x is the first number a, and 7x is the second number b. We have to use these numbers in a manner we can equate to the second equation, and that is by taking their least common multiple. Their LCM is 3 times 7 times x, or that is 21x. Now that we completed the other equation, we can combine the solved LCM with the given LCM, or that is 21x as equal to 210. Divide both sides by 21 and have x as 10. With the multiplier known, we can find the numbers, the first one of which is 3x. So a is 3 times 10, giving a as 30. The second number is 7x, or 7 times 10, giving b as 70. The fifth example is some kind of transformation where we are to identify a certain number x, which, if added to the ratio of 5:8, will transform the ratio into 1:2. Again, we denote the required number as x. We start by transforming the ratio into fraction, making it 5/8. From the premise, it states that we are to add a number to both numerator and denominator and transform the ratio into 1/2. If we cross-multiply the parts, we end up with twice of the quantity 5 plus x, and this is equal to 1 times the quantity of 8 plus x. Simplify the equation and get 10 plus 2x is equal to 8 plus x. Transpose terms to collect similar terms, and that would be 2x minus x as equal to 8 minus 10. After simplification, we get x as -2.